So this video is about comparing and rounding decimals specifically, and we can expand this or use this as an application of comparing and rounding any sorts of numbers that we write in decimal notation, which decimal notation we just mean writing with the place values, ones, tens, hundreds, thousands, tenths, hundredths, thousandths, etc. And so, as that indicates, we need to make sure we understand and remember the place value for decimals, and also that we make a transition between the ones and the tenths from numbers that are representing whole values and are progressively getting bigger as they go to the left, and numbers that are representing partial values, parts of integers, and are getting smaller as they go to the right, even though the words that talk about them, millions, hundred thousands, 10,000s, etc., are actually getting bigger. And if you need a review on that, go back to the place value for decimals lessons. But first, we want to talk about rounding. And so when we round any sort of number, we are taking an estimate for what the value of the number is. For example, if we had the number 24 and 693 thousandths, perhaps we don't need all of that precision. We only need something to the 10th. So if we're going to round to the 10th, we find out where the 10th place is in our 24.639, which is at the 6th. And it's not that we're going to use the 6th. When we round to the 10th, we are actually going to use the 100th. So whatever place value is immediately to the right, that is the number that we are going to use to round when we actually go to wanting to round the number. So we have 24.639. We want to round it to the nearest 10th. Since we're rounding it to the nearest 10th, we want to use the 100th, which is the place value immediately to its right. And recall from rounding with whole numbers, which you've had lots of experience with, that if the number is from 0 to 4, whatever place we are using, if it is from 0 to 4, it remains the same. And if the using place is 5, 6, 7, 8, 9, we round up. In this case, it's a 3, so the rounded number just becomes 24 and 6/10. So that's rounding to the tenths. Now, let's say we wanted to use not the tenths place to round, but we wanted to round to the nearest hundredths place. So now, if we are rounding to the hundredths, we're going to use the place value immediately to its right. So we're going to use the thousandths to round. Here, our hundredths, let's make that a little bit bigger actually. Here we go. Now our hundredth is 3. That is the number we are rounding to. The number we are using, or the place that we're using, is the 9. Now a 9 is big. It is almost up to the next place value, so we're going to use this to round up because our thousandth place is from 5 to 9, and this becomes 24.64 when we round it to the nearest hundredth. So what I'm going to ask you to do is pause the video. You're going to round each of these numbers to the nearest hundredth and the nearest thousandth. Go ahead, pause the video, and come back when you are ready. All right, so let's start. We'll call it number 1 with 3.0784. If we are rounding to the hundredth, we are rounding to the hundredths place. So we're going to use the thousandths. 8 is larger than 5, so to the hundredth place it is 3.08. And now if we want to round from the thousandths to the thousandths, we're going to use the 10 thousandths. 4 is small, it is less than 5, so we are not going to round that place up. It becomes 3.078. Moving over to number 2, which we'll call the 48.3063. To the hundredths, the 0 is our hundredths place, so we're going to use the 6. The 6 is bigger than 5, so the hundredths place gets rounded up to 48.31. And now if we want to round to the thousandths place, we're going to use the 10,000ths place, which is the 3. 3 is smaller than 5, so there is no rounding up that happens. 48.306. For number 3, which is our smallest number here, we have 0.05739. If we want to round to the hundredths, we use the 7. We round to the 7, so we use the 3. 3 is less than 5, so no rounding up here. 0.057. Actually, sorry, my mistake. That was a thousandth. So 0.057, that's for the thousandth. If we're going to round for the hundredths, we're going to round actually for the 5. 7 is bigger than 5, so it becomes 0.06 is the rounding to the hundredths place. And finally, for 458.1975 to the hundredths place, which is the 9, we're going to use the 7, which becomes 458. We can't round it up to 10 per se, but we can round that 9 up to a 0 and add 1 as if we were adding to the tenths place to make it 458.20. Notice, even though we don't need that 0, we're going to keep it to show that it's rounded to the hundredths place. And then for the thousandths place, we have 458.198 rounded up because the 10,000ths place is a 5. And the other part that we want to talk about with decimals today is comparing decimals. And comparing decimals just means finding which decimal is larger or smaller than another decimal. And what we actually use, we don't use the word smaller in math, we use the word lesser. So which is larger and which is lesser than another number. So we can take them in groups of 2, or we can talk about them in whole groups of numbers. So let's say we want to order these decimals from least to greatest. Well, anytime that we talk about comparing decimals like we do anything else, we just move from the largest place that we have down to the smallest place. And then as we come across those place values, whichever numbers have larger place values are larger than each other, and whichever numbers have a smaller digit in those place values are lesser than the other numbers. So here we all have a tens digit, notice tens, not tenths, a tens digit of 5, and nothing above that. So we've gotten to the tens and we can't do anything about it. Now we look at the ones. Well, we have a whole bunch of 53s, but we have one number that is a 4 in the ones. So that means it is actually the greatest of our numbers. We're going to move it because we're ordering them from least to greatest. We know that this is actually the greatest of the numbers that we have because the ones place is the biggest. So now let's look at the rest. We have to look at the tenths place next because, as we said, we're going from left to right. Here we have 2 numbers, underlined in green, that have a 6 in the tenths place, but we have one that has a 0 in the tenths place, which means that it is actually smaller than 53.607 and 53.670 because the tenths place is smaller. It is actually the smallest number that we have, so that is the least. And now we look at the hundredths place. The hundredths place is a 7 and a 0. A 7 is greater than 0, so this number is actually larger than that number. So in this case, it turns out to be in the order that we had it before. Going to put some less than signs in there. So 53.067 is less than 53.607, is less than 53.670, is less than 54.067. Look at one more example before we go to the practice problems. Here, all of our 10s and 1s are exactly the same. They're all 18s. So now we have to look at the tenths place. Here we have only one number that has a different tenths place, which is a 5. That 5 is greater than 3, so it is actually the greatest number, the 18.503. Here, now if we're looking at the hundredths, we have 2 places in the hundredths with a 5. But one number that has a 0 in the hundredths. Since a 0 is less than 5, that is a smaller number, so it's the least number. And now we look at the thousandths. Even though our number 18.35 doesn't have a thousandths place showing, it always has a 0 at the end. And here, the 3 in the thousandths place is actually greater than the 0 in the thousandths place, which means that whole number is greater than the number before. So here we have 18.305, 18.35, 18.353, and 18.503 from least to greatest. And now for the last thing that you're going to do is you're going to practice by ordering these sets of numbers from least to greatest in all of the cases. Go ahead, pause the video, order them from least to greatest, and then unpause, and we'll go through the rest. Well, for number one, again, we're going from the largest place values to the smallest. We see that all of the tens places are the same, but the ones is different, so 10.99 is actually the smallest. In the tenths place, we have a fours, some fours here, a 9 here, and a 3 here. So that 3 is smaller, but it's still bigger than 10.99. And the 9 is the largest, so we're going to put it over here. There's nothing with a larger 10th place there. And then finally, for 11.47, the hundredths place in 47 is smaller than the hundredths place in 49. So the order we want is 10.99, 11.305, 11.47, 11.49, and 11.9. For number two, we're looking at, again, ordering it from least to greatest. If we look at the tens place, there's only one number that has a tens place, so that is the biggest. And there's only one number that has a ones place that's not 0, so that is the next largest number. So now we have these three numbers that we're looking at here: 0.076, 0.706, 0.607. As far as the tenths place go, there is a 0 in the 0.076, a 7, and a 6. And the tenths turn out to be enough. We can see that 7 is larger than 6, is larger than 0. And that is our entire set of numbers. 0.076, 0.607, 0.706, 1.03, and 10.3. And now for the last set of numbers, again, going from least to greatest, from left to right. All of the hundredths places that are the same, but we have a few things that are, or we have one thing that's different in the tenths place, or the tens place, as a smaller 2 than the rest have 4s. The same is true for the ones place here with 340. So now we just have to look at 342.86, 342.806, and 342.086. As far as the tenths are concerned, there's a 0 here as compared to 8s with these two numbers. So this number is the next greatest number. And then we don't have to go any further than the hundredths. The hundredths place in 342.86 is a 6. It is only a 0 here. So the 0 is smaller than the 6, even though 806 in the decimal places is larger than just 86, but because it's in decimals, the 6 hundredths is greater than the 0 hundredths. So we have 342.608, 340.888, 342.086, 342.806, and 342.86 as our order from least to greatest. So just as a review, when we round decimals, we always look at one place, the place that we are rounding to. Whatever we're rounding to, we use the place value that is one smaller to it to do the rounding. And when we compare decimals, we just go from place value to place value, seeing how the numbers compare to each other and ordering them as we find them.